Okay, I've modified the code slightly because when we use the visualizer, we don't have a file system, so we can't read in a file. But what we're interested in is getting a handle on this piece of code here from line 3 to line 17 that does the search. And so since there's no file system, I've just hard-coded 5 names and numbers. Okay, they're not very unique numbers, but 5 names and numbers into our list. We still have the process of we read in a list of tuples or we create a list of tuples, we're going to sort it, and then we're going to do a search on it and look for this particular name, which I've set up here at the top. If we find it, okay, we print it out. Otherwise, we return a special result, which is this tuple that's empty strings, and we return that, we look for that, and we print out that it's not found. So all of that stuff stays the same. Now, this piece of code from line 3 to 17, I have taken out all the comments because the computer doesn't read them, which makes it shorter and less code to look at in the visualizer. So I've tweaked the code down. Now remember I said visualizer is great for understanding what's going on, but it's not good for big programs. I had to shrink the size of the program, the number of lines of text, down to get it to fit. And it almost fits in the visualizer. So let's take a look at it in the visualizer. It prints out, it's not quite wide enough. I can maybe go in and tweak the width, but you do have a scroll bar down here. But the code I'm going to give to you anyhow. So let's look at what happens when we run through it and visualize the execution. Again, it's not quite big enough. Let's make our output box a little bit larger. And let's start running for it. The first thing that happens is at the top level, it sets the variable look for to my name. Okay? And then it's going to have this function, binary search. Now, as soon as it sees that it's a function, it's going to skip right down to the next thing because it's going to either be syntactically correct or not, but it's going to create, yes, binary search is a pointer at a function that takes list of tuples and look for as the named things. Now, the next thing, it's going to take a little bit of searching for the Python parser to find the end of the statement, but basically it's going to say line 19, we've created some data. And the data has these tuples in it, 5 of them, 0 through 4. You notice it ends at 4. And each one of the tuples is, notice that it says it's a list of tuples. Each tuple is a name and a number. The next thing we do is we call the built-in sort function that we demoed with some of the list stuff because it's not sorted yet. And we sort it into order. Now, interestingly enough, okay, we still have 5 tuples and it's sorted in order. Now we're going to do the search. That's the piece that we were after to start off with. So let's go zooming through the search and see how it works. As soon as we call a function, it creates a new frame. Just like a list comprehension created a new frame with values. And the particular variables that it is associated with this frame are list of tuples, which is a pointer to the same data that we passed, and look for, which is a parameter. That looks pretty good. Now, what we'd like to have is either it's going to return a successful tuple that it found, or if you look in the code at like line 17 or line 5, you'll see that it returns an empty one indicating it didn't find it. Now, what are our cases? Our first case is we want to say if the length is less than 1. That's all empty lists or all lists that have negative numbers of things in them. And since an empty list would not be a match, is this an empty list? That's the question. Well, no, so it's going to skip over that. Then it's going to say if the length is 1, so is there just one item in this list? No, there's 5, so it's going to skip over that. If the length is 1 again, the previous one had some other criteria. This time, if the length is 1, nope, still not 1. It's going to skip over that. So we know that the list is at least too long. Because it can't be negative, it can't be 0, it can't be 1. And we have natural numbers, which means that what's the next number that is larger than 1 is 2. So it's 2 or more at this point, and we're guaranteed that. Which means we can divide the length in half. Notice that, again, I'm going to point out for the second time that it uses a double slash to indicate integer division. So what's it going to do? it's going to take 5, which is the length, one more than the subscript, divide by 2, and that's going to give us 2. And so mid gets set to 2, not 2.5. That would be floating point division with a single slash. So it gets set to 2. Now, what is the sub 2 entry in the list? It's this John Dykstra fellow. And it's going to say, yeah, we're going to look at that. So list sub mid, which is John Dykstra, sub 0. What's the sub 0 in the tuple? Is his name right there. Is that equivalent to what we're looking for? Well, looking for over here is this. Are those a match? No, those don't match. So it's going to go to the next thing. Now it's going to say, is looking for less than whatever that mid sub 0 is? And is Philip Schlump less than Dykstra? Well, is P less than J? Remember our ASCII table? And they counted up, so no, it's going to be a later in the alphabet. So it's going to skip over that one. And is it greater than? Now, legitimately, at this point, I know that it's not less than. I know it's not equal, so I could just return binary search, but it does have the test in here. It's greater than, which means we're going to call this great search routine that we have that searches sorted lists. And we've partitioned the list into what are the pieces. And we haven't partitioned it very usefully because we're going to have 3 instead of 2. We could have done a better job and said mid plus 1 there when we passed it, but we didn't. Okay, it's got an error in it, yes, but it's still going to work in this case. Now, the binary search, notice that this time it's sub 0, sub 1, and 2 are pointing at different things up here. You know, it's just arrows. It hasn't actually duplicated the data. It's just created a new set of pointers at the things that we passed. Now, is the length of this list right here 1? No, it's 3. Okay? So it's going to go through all of its initial cases. And since it's 3, it's going to divide by 2, giving us, yes, 1, which is Mary Spender. And it's going to say, is that a match? No. Is it less? Is it greater? Yeah, it's greater. So we're going to call this nice search that we have on this list. And guess what? We still have the same error in it. Look at that list. It's 2 long when it should only be 1 long. But it's going to work in this case. And we're going to look at our new list. Again, the list is too long. It has gotten smaller, so it's likely to succeed. It's not a 1. The mid is 1. 2 divided by 1 is 1. And there it is. It finally matches. And we have a return value, which is a pointer at this tuple. All right. Now, we're going to go back and return. Remember, we've called this thing multiple times. We're going to return. And it's got a return value, and it's going to return again. And it's got a return value. It's going to return again. And found result now points at this tuple over here. Now, found result, is it empty? No, it's got a name there. So it actually succeeded in finding. And there it is. We print it out. Found. Now, you notice when we went through it and we visualized it, we found some things we didn't like. Okay, we're going to fix those. But this gives you a clue that lots of times you can build code that for a particular test looks like it works. But you have to be really thorough in testing. Is there a case where our thing that we didn't add 1 to mid causes a problem? Okay? So quite often when you build tests, you've got to build a whole successive set of tests and work through those tests individually. We're going to add a set of tests to this, and we're going to work through it because there may still be cases where it fails. In this case, it worked, but not because we got the code right. It worked because we got lucky. But this is the subtle thing with testing. and why it's so important to test, and why things like formal proof are critical pieces if you want code that works all the time without exception. Okay, I'm going to get this piece of code to you. This is the second part of the homework. The second half is to implement this. I expect you to type it in. I'm not going to make it so you can cut and paste it. So when I send it to you, I expect you to type it in. I have great hopes that when you type in this piece of code, it's just long enough that you're going to have errors in it. But learning to type it in is part of that muscle memory of, I've learned these patterns because I've done them over and over again. And I know that when I type this, this is the way I'm going to type it. And after a while with muscle memory, you're going to get to the point where you just know that this is the way you type this in. Okay, and your fingers just do the fingering thing, and magically you get the piece of code you're after. So you're going to get, yes, I'll be mean to you, an image of the file, not text, not PDF, but it is going to be there for you. So you get to type it in and you get to run it. And that's the second half. The first half, I'm going to give you the read part. You get to implement the first part of it, or the bottom half where it does the linear search.